Okay, we're going to do some more cycle testing, but we're going to do it on a production unit with the new shim provided by UEI. Yes, it does actually have a routed out little bit in there. It's actually very nice. Those little tooling holes there are designed to get the routed edges. Yes, it's made out of regular FR4 fiberglass, and that is going to sit. Whoops, sorry, we've actually got this hooked up. I'll show you in a second. But that actually just sits over. Yeah, sits over there like that, and that just wedges in there nicely. And it goes back in along with the new knob, of course. And we've actually hooked up some wires here to the off position of the unit. So when it's in the off position, we'll actually be able to measure the contact resistance here. But we've actually changed our jig over here to actually measure this. So we're using an ADC on here with a parallel resistor in there, a divider resistor, and then a parallel resistor just in case it opens, and then we can calculate the actual contact resistance. What does our contact resistance go up to, David? About 10 ohms. Anyway, we've tested it, and our nominal contact resistance is about 0.9 or something like that. So, of course, we expect that to vary a lot and change as we cycle through the automated testing. But anyway, we're going to try it with the new shim, get our automated tester, and whack it in there. So, let's give it a whirl. Alright, so I've got the new meter together with the new knob and the new white plastic spring indent thing in there, plus the new shim, which is 0.5 millimeters thickness, by the way, for those playing along at home. And it's still indents, but it is not as clicky as it was before. It sort of changes the nature, changes the feel of the range switch. Some people will really love that new feel, others won't. Others might want a light clicky feel. Anyway, we've got our contact resistance here now, 0.9 ohms, and that's not, variant at all. That's rock solid. So I expect that, of course, to increase. We're consistently getting under 0.9, and UEI have done some tests, and they're consistently getting under the 1 ohm mark. But yeah, anyway, so the plan is probably we'll run 1,000 cycles on this first, take it apart again, have a look at the contacts, and then if 1,000 cycles is okay, then we'll maybe do 5,000 or something like that. Do increments where we're not going to go bang for 25 or 50,000, because that doesn't tell us at what point, if any contact wear starts to happen. So let's give it a whirl. Just pushing buttons randomly.
This will take a little while to set up, just because.
Still working on the software. Still working on it.
Oh, the software's good.
Oh, there we go. Software's good.
Software's good. Couldn't see it.
All right. There we go. All right, we're going to set up 1,000 cycles. Going to go for it.
1,000?
1,000. Let's do it.
Okay.
That's the old meter. We're just going to give the test first. Yep. And for those who are wondering, yes, it does do a full cycle all the way with LBJ from one
we can show that.
end to the other.
I can just lift it up now.
Oh, right. And
there you go. You can have a look.
Have a look. And it's right over it.
It's on the dot.
It's on the dot. There you go. And yes, we'll keep an eye on it. All right. Recow. This is way too much fun. All right, so let's have a look at this puppy after 1,000 cycles, which is 1,000 cycles one direction, of course. So, like one sweep one way, that's one cycle. Back is 2 cycles. So let's check it out. Because we didn't want to run the whole, like 10 or 20,000 or something without knowing what it's like after 1,000. And got to remember also, this one has been run like at least a couple of hundred times in various other test jig testing and things like that. So it's not a particular, as well as other use. So it's not a particularly virgin meter in that respect. But this is the first time it's been run with the new shim. So, which of course puts some extra pressure on the range switch. So let's get this puppy open. Come on. All right. Let's have a squiz. Okay. And you would have seen in the testing that there was variation in the contact resistance, but it basically didn't fail. There were no opens or anything like that as far as we saw from the data. So there we go. Come out wherever you are. Here we go. Just got to be careful because we want to put this back in. And oh, all right. Let me try and get this out. Okay, that was a poor effort, but I got it. Oh, contact came out. That's not unexpected. Like, there's not much holding those contacts in. So let's flip this over and have a look at our contacts. I'll whack the macro lens on. Get that under the mantis, but there's some kind of crud. Hang on, I'll put it under the Tegano. Some other stuff in that could be fiberglass. That's from just the inside, raw inside of the ring, something like that. Let me get under the Tegano. Okay, there we are under the Tegano microscope. It probably looks worse than it actually is, but you can see all that crud around there is certainly the fiberglass that's come off the edge of the hole in there. So it would have been better if that was plated, I guess. But after 1,000 cycles, so it's pushed some of that crud into there, but it's not. Basically, we're looking for really the metal as the stuff that really concerns us, and that's not, those markings on the gold pad aren't really a huge problem, especially when the contact resistance we've proven hasn't really caused much of a drama. There we go. Maybe some plating starting to wear off the contacts, I don't know, but no, they're still looking really good, Nick. So that combined with the board, it's not too bad. So the real tester, we whack it in, we'll do like 10,000 cycles next and see what happens. But no, there's nothing seriously bad there at all. The contact resistance is still good. I think we haven't run the numbers yet, but I think it's still like always under 1 ohm or something. So that's fine.
Just
yeah, it's going to stop
2,
it.
1, yay!
It finished. We programmed it to get to 5,000. So that's what, 9,000? I guess we now have to look at the contacts, right? I've got to shoot a video. Should I do that live?
Yeah, this is how I make sure there's no skip steps. There's just a permanent marker on the shaft and a permanent marker on the plastic. It's pretty secure. This side is set to be secure. This side's set to slip like a torque wrench, so I can't put too much force manually into the dial. So to calibrate it, I just go whoop, and then it moves all the way to one side.
I'm not sure if people are hearing that, but yep. For those that didn't hear that, it's basically, as I said before, it's hooked up. Those wires are hooked up to the off switch position, which is actually the reset line of the micro. The micro, like the switch, also holds it in reset. Holds the micro in reset. So, and when you hook instruments up to it, or when you hook pull-ups and parallel resistors and everything else, it just screws with the pull-up on the reset line and it doesn't switch on. So, anyway, still cycles. Now, I want to shoot this on a regular camera. Doing stuff in this lab is hard. There's so much crap everywhere, and every video requires different positions for gear and cameras and whatnot. All right, here we have 133 again. We've got we've done 9,000 cycles. I think we did 1,000, and then we checked it. Then we did 5,000, but we had to go that night, so we had to take the computer away, the login computer. So we took it away, and we came back today and we did another 5,000. So that makes 9,000 cycles, and we were measuring. We had a few issues with the position of the meter in the jig, and that was causing a real problem with our contact resistance measurement. So we've got we're going to get some data that's corrupted. We were getting roughly about 2 ohms, something like that, contact resistance after, towards the end of that. So it was still going good. And one cycle, of course, is from one off position to the next. It's not cycled all the way back. So one cycle is from here over to here. So to go back would be 2 cycles. That's how we're counting. It's just how our jig, how our jig works. So let's pop the board out. There's our little shim. Yeah, we've got some crustiness under there. So some of the fiberglasses, yeah, just worn off that. So guess that's to be expected. Maybe we could add some lube under there or something, I don't know. Oh, actually, yeah, I see the problem with the fiberglass shim is going to be the fiberglass dust around the outside of that. So that's going to be a problem, actually. So I'd expect this isn't going to be particularly clean inside here. Yeah, we didn't see that after 1,000 cycles. So that's it's not entirely unexpected. I didn't know they were going to do a fiberglass shim. And I don't think, a plastic one, I guess, would be better, but they were able to use the fiberglass to route out a little slot in it. So it's actually rather clever. Oh, there we go. No contacts came out this time. There we go. Oh, no. No, there's a bit of fiberglass around the outside. But apart from that, that looks okay. So that wear looks bad, but the contact resistance is still great. It's still like a couple of ohms. It's really quite nice. So that, put a bit of spit on that. So that's like, I can just wipe that. So it's actually, those contacts are pretty good after 10,000. You can see in there that the trace between those 2 contacts is it's worn off. The solder mask is worn through. But that's a lot of cycles, right? And that's continuous back and forth, at a high rate. Some people say, oh, it's too, we're doing it too fast and it's melting, it's going to melt things and stuff like that. I don't know. I didn't think it's that fast. I'm not. And now we'll have a look at the contacts. So you can't say I'm not taking my chances doing this live. The contacts down in there aren't, they're fine. There's nothing wrong with the contacts at all. I don't see that as a real issue. Let me have a look at that on the Mantis. Sorry, I'll go back. Yeah, no, his contacts are good. Don't have to worry about the contacts. I think they're great. So there you go. That was 9,000 cycles. So the fiberglass shim, it's great. We were, about 2.7 ohms on the switch. So we can put that back together and measure it. So if I do that, we effectively have the reset line. We're actually shorting out the reset line of the microcontroller. Wiggle, 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 yeah. Nah, see? It's all hunky-dory. So, yeah, it's all good. So that's done 9,000 cycles now. So apart from the fiberglass dust in there...
11? Yes.
6,000. We did another 1,000. Yeah, you're right. It's 11,000 cycles. Thank you. There you go. 0.8 ohms. I mean, that's done 11,000 cycles. 11,000 cycles, and we're on 0.85 ohms. And there's like, if you wiggle it, like it changes a little bit, as you'd expect. But and 0.9, that one's longer for some. It has always been slightly higher for some reason in that position. Maybe it's got. I shouldn't have longer tracks. The tracks are only like shouldn't add much, but maybe it uses a different set of contacts or something over in that position. All right, we've got the serial number 133. It's now done approximately 25,000 cycles with the new shim, and the contact resistance is still okay, but it's basically, I would deem it to be failed now, because it's, if we go into the diode test mode, the knob has the problem it will do it. Yeah, there we go. So we've got that dicky contact again. So, but that's our jig failed actually at 25,000 cycles. We had a problem with the drive motor and everything else. So I'm not sure if that's put any extra force on the switch or whatnot. But that's what we've done now. 25,000 cycles. So let's have a look. Although it, as an actual solution, it works. It seems to work very well for the contact resistance, and of course the switch wobble is fixed, and the intermittent range switch I think all those problems are now. I think it does actually fix those, so that's good. Okay. Let's have a look. Actually, not much more dust than previously. Similar. I'd call that similar. Shim, of course, is it seems to have worn on. Maybe there was a burr of plastic or something under there. That no, or is it the holes? Yeah, it seems to have lined up with the holes to do that. So that's interesting. Okay, let's have a look at the contacts first of all. And the contacts look very good, and you can see the dust caked under there. But for 25,000 cycles, those contacts look really quite nice. So that doesn't seem to be a problem. Once again, it probably looks worse than it is with the dust. It's a problem, but the actual the contacts on the PCB still look okay. I mean, you know, it's had 25,000 full cycles on it. That is quite violent. So I don't have too much of a problem with that. Actually, with the actual wear on the contacts, it's, you know, not as I mean, it's not perfect, but there we go. If we get rid of all that, those contacts actually look pretty good. There you go. So it's just really the debris that's caused that. There's maybe some wear between there. Of course, the solder maskers are worn off in there, but that's pretty good. For 25,000 cycles, I've got no problems with that at all. So even with the extra pressure from the shim, that looks pretty decent. Now, if we actually have a closer look at the fiberglass shim here, you can see that the dust is actually doesn't appear to be the fiberglass itself. It's a different color, and that's got to be from the plastic of the case. So it's not the fiberglass that's wearing down, it's the actual case itself. So does that mean you know, we could maybe have some grease in there, might actually help some things perhaps, because that is definitely not the fiberglass dust there. That's coming from the plastic case. What is it, ABS or something like that? It has to be. That's definitely not the fiberglass. Anyway, there's no wear on that hexagon there. Looks fine. And after cleaning up the contacts, wiping away all the crud, putting it back together after the 25,000 cycles, it's still good. It's still good to go. In fact, the resistance is I'm having a hard time getting that to be anything but sort of rock solid that it's sort of begun with. So, you know, maybe if I take it off, like rotate it a slight amount, but well, it's gone off the contact now completely, of course. But it really seems quite solid. So I'm that, you know, maybe it was just, you know, a little bit of gunk in there. You just wipe the contacts and it's good to go. Let's actually reproduce the diode mode here. Try and do that. That's pretty good. Look, I can't reproduce that at all. So that seems to be still a rock solid solution after 25,000 cycles. Nice. Alright, this poor little sucker has now done, I believe, 51,000 cycles, give or take. And, well, it still works. The range switch still feels the same as when we put the shim in. Yeah, we're in diode mode. And, oh yeah, there we go. Got it to wiggle a little bit, but not a huge drama after that number. And once again, last time we cleaned it, it was fine. So that was, wonder if that's the case now. We'll find out. Don't know how many more insertions and removals this board is going to take. It's still doing okay. That was a bit brutal. Wow. Wow, can't really see the plastic again, so I guess the worst of that plastic is over. That plastic wear, worst of that is, it's over, is it? There we go. Wow, there's hardly, I mean, there's some. Wow, actually, there's hardly anything. So yeah, I think maybe there was like a burr sticking up there originally, and that's what really wore down. But that looks in fine condition. The switch isn't going to survive. That plastic clip's not going to survive too many more insertions. Wow. Wow, that looks pretty good. That's after 51,000 cycles. Yeah, I mean, it's, you know, it's kind of what you'd expect, I guess. But yeah, there's a lot more wear on this second outer ring. Once again, we got some of the plastic. That's not fiberglass. You can see the color in that. The old spit on that. I might give that a little wipe with some isopropyl alcohol, perhaps, before I put it back together. But see, that actually, the contacts are still fine. Like, they seem to be okay. I mean, you know, you'd expect that sort of wear after 50,000 odd cycles. So let's, yeah, oh no, it's not a huge amount of, yeah, it's very clean now. Wow, so it was really only that initial number of cycles that caused the problem. They look to be in pretty good nick. No worries whatsoever. And there's really hardly any metal wear on that. And the thing we're of course concerned about is, you know, metal scraping off either the pads and or the contacts and then get in between, you know, pads and shorting them out and stuff like that. And we really don't see any major evidence of that, really. So that's very impressive, I think, after 50,000 cycles. 51,000. Nice.